Hi everyone, welcome to another sketchbook session, and today we are going to look at the animal at which evolution went against the norm. It went more Picasso than a Picasso painting before Picasso even existed. It looked at every single vertebrate on the planet and went, nah, we're not going to do what we've done there. Today we are looking at flatfish. Before we get into today's video, just a quick reminder to subscribe, because not only do we talk about flatfish, we talk about roundfish and squarefish and particularly starfish, because I am a channel all about the weird and wonderful things in our ocean, particularly rock pooling. Every single Wednesday I release more videos about the ocean, the weird and wonderful creatures, rock pooling, and I paint them as well. So if that sounds like something you're interested in, click subscribe. So, flatfish. Fish that are flat. Is there really a whole video's worth to tell you about these guys? Isn't the name self-explanatory? Well, no. These guys are an evolutionary miracle. These guys have done something that no other vertebrate, so a creature with a backbone, like me, like fish, other fish, like all of literally loads of creatures. Why can't I think of any? Bears, monkeys, seahorses, they're fish. And you get the idea. Has ever evolved like thee. And not only that, it's worth talking about because these creatures are actually overlooked. I mean, have you seen their camouflage? It's amazing. But really, for something that we can see right on our own rocky shores, this is such an example of evolutionary mastery that you totally need to hear about it because it's gonna blow your mind. So what makes a flatfish so special? Well, the main thing is that it's flat, but if you look at its skull and its head, both eyes are on the top of its body. Now that might not sound so special, but look at every other vertebrate on the planet. Look at turtles and birds and humans and bears and whales and seals and basically every other vertebrate. Symmetry is so key to their being. Every other vertebrate, you can cut them in a certain way and they will look the same. Crocodiles, wildebeests, they all have symmetry within their bodies, and there is nothing symmetrical about the flatfish. It's asymmetric, and it's the most asymmetric creature vertebrate on the planet. And that's really incredible because it's taken something, a constraint that every other vertebrate has to evolve into. It has to evolve down the lines of saying we still need to look equal on both sides, and decided to turn against that. In fact, it shows that evolution can turn against that. But what is even more remarkable than that is the fact that these creatures, believe it or not, these species actually start their lives looking symmetrical, looking like little fish larvae. When they first, on their first stage of larval development, when they're teeny weeny, they look like a normal fish and have symmetry. And it's as they develop and they kind of metamorphosize into this weird flatfish, almost like a bad 2D drawing of a fish that a kid would have drawn or something, fish, as it gets older. That is really, really weird, but also really cool because it means you get left-eyed fish and right-eyed fish. Yes. So if you start off with two eyes at the side of the body, and as they grow, one eye will move around that body into the other side. That will either be a left side fish or a right side fish. Most of the time, it's the left eye that moves to the right, but sometimes you get the other way, which means that just like humans being left and right-handed, you can get fish species that are left and right-eyed, flatfish that are left and right-eyed. Weird, right? What makes this more incredible is if we start to think about, you know, this is a really major transformation. What other side effects could, you know, basically blending and moulding your body from looking like a normal fish into something that's pretty much 2D. What could that do? And one of the key things that gets moved and especially affected in the skull is actually your senses, your eyes and your ears. And what's a particular issue at such a larval stage is basically your ability of balance, to tell what is up, right, left, down. Because you're so small, you need to know where the top of the sea is, you need to know where the sea bed is, and you need to be aware of your surroundings so that you don't just become a spiralling tiny larval mess to be eaten by almost everything else in the sea of that size. So what controls this balance, as in humans and in fish, are the eyes. And instead of the ears in humans and mammals, it's the otoliths in fish, which are tiny little bones which look a bit like tree rings, tiny circular tree rings that vibrate and spread sound. And they also control balance. Now what we've found with flatfish is that actually, because the eyes are moving, and if the eyes start to move, they can get disorientated. You know, they're starting off knowing that this is up and that's down, and if the eye moves over there, then that's up and that's down, and left becomes up and right becomes down. It's very confusing. So these fish species have actually kind of taken that sensory part of the eye back and put it into the otoliths. So there is more emphasis on them, so the balance kind of within the ears. Now for them not to get confused, actually at the stage that the flatfish looks like a normal fish, it's the otoliths, and especially one of them, the emphasis is on, and the fish will often swim sideways anyway. So right from the get-go, right from that fish living in existence, there is a sensory push for this to become a flatfish and for it to know, you know, the differences of left, right, and it's going to, you know, change. And that's there to stop this process becoming one that ultimately means the fish don't live and don't survive to the adult stage, which I think is a really incredible way to show how complex evolution must be, but it has to be for a reason, right? This reason is basically it's occupying a niche, a weird area of the sea that hadn't been exploited by other species. They are really good at camouflage. The fact that they're 2D means that they can kind of go under the sand or on top of it, blend in and can't be seen. And these guys are kind of ambush predators. They sit there and wait until a poor crab or a shrimp or a mollusk or something is walking along, thinks that it's just walking on sand, and then it eats you. And the fact that it has two eyes on one side of its head means it has an extra wide periphery vision so that it can see all around and look out for the stuff that's going to come along for it ready to eat. Now that is a crazy evolutionary journey of millions of years that we can see right on the rocky shore. I think that is crazy and something that is really underrated. You know, you see a flatfish and you think, oh, that's cool, but really, these fish are evolutionary examples for all the creatures around the entire world. That includes things like coral reefs and rainforests and all these things. They are the exception to the symmetrical rule, and that for sure is worth talking about. I hope you enjoyed today's video. This is part of a series of sketchbook sessions, so if you like that and want to find out weird facts, I've got a ton more of these videos in a playlist here, so go check that out. Make sure you subscribe and like and click the bell and all the notification things so that you don't miss out on finding cool stuff like this. I wouldn't want to miss out, and I'm me and I'm doing it, so you shouldn't want to miss out more, because I know what's coming up and you don't. Have a good week, everyone. See you next time.